Slime is one of those strange things that seem simple at first glance. It's squishy, stretchy, gooey, and often brightly colored. Kids love playing with it. Social media is filled with videos of people poking and pulling it, and toy stores have entire shelves dedicated to it. But if someone stopped you and asked, "What exactly is slime?" the answer might not be as obvious as it seems. After all, slime doesn't behave like a normal solid, and it doesn't act quite like a liquid either. It can hold its shape one moment and ooze through your fingers the next. It appears in nature, in science labs, in toys, and even inside living things. So what is this mysterious substance, and why are humans so fascinated by it? That's what we're exploring today, right here, on History of Simple Things. When most people hear the word slime, they probably picture the colorful toy that became wildly popular in recent years. But slime existed long before toy companies started packaging it in plastic containers. The word itself generally refers to any thick, slippery, semi-liquid substance. Depending on the context, slime can describe everything from the mucus produced by animals to the goo found in swamps and ponds. In other words, slime isn't one specific material. It's a category of substances that share similar properties. What makes slime unique is its ability to flow like a liquid while also resisting movement like a solid. This unusual behavior is what gives slime its signature stretchiness and squishiness. Scientists classify many slime-like substances as non-Newtonian fluids. That may sound complicated, but it simply means they don't behave according to the normal rules that govern most liquids. Water, for example, flows predictably, no matter how gently or forcefully you stir it. Slime doesn't. Pull it slowly, and it stretches. Pull it quickly, and it may tear apart. Press on it, and it can feel almost solid. Let it sit, and it slowly spreads out. This strange behavior is a big part of what makes slime so fascinating. To understand slime, we need to zoom in to the microscopic level. Most toy slimes are made from long chains of molecules called polymers. A polymer is simply a large molecule made up of many repeating smaller units connected together. Plastics, rubber, and even DNA are all examples of polymers. When slime is made, these polymer chains become linked together in a loose network. The chains can slide past one another, but they're still connected enough to hold the material together. One reason slime became so popular is that it's surprisingly easy to make. Many homemade slime recipes start with school glue. The glue contains polymers that are already present but not yet connected strongly enough to create slime. When a substance such as borax solution or certain contact lens solutions is added, chemical links begin forming between the polymer chains. Scientists call these links cross-links. As more cross-links form, the liquid glue transforms into a stretchy, gel-like material. Suddenly, what was once a runny liquid becomes something entirely different. The amount of cross-linking affects how the slime behaves. Too little, and it remains sticky and messy. Too much, and it becomes stiff or rubbery. Finding the right balance creates the satisfying texture that slime enthusiasts enjoy. While toy slime gets most of the attention, nature has been making slime for millions of years. Some of the most famous examples come from animals. Snails and slugs move using a layer of mucus that acts as both lubricant and adhesive. Without this slime, they would struggle to travel across rough surfaces. Fish also produce slime coatings on their skin. These layers help reduce friction while swimming and can provide protection against parasites and harmful bacteria. One of the most remarkable creatures in the animal kingdom is the hagfish. When threatened, a hagfish can release enormous amounts of slime into the water. Within seconds, the slime expands dramatically, creating a thick cloud that can clog the gills of predators. It's one of nature's strangest defense mechanisms. Even humans produce slime-like substances. Mucus in our noses, throats, and lungs helps trap dust, germs, and other particles before they can enter deeper parts of the body. Without it, staying healthy would be much more difficult. Although slime-like materials have existed forever, slime as a toy has a much shorter history. Commercial toy slime first became popular in the late 20th century. Early versions were often sold in small plastic containers and featured bright green colors that emphasized their gooey appearance. Part of the appeal came from the fact that slime felt different from almost every other toy. You didn't build with it, drive it, or throw it. Instead, the experience was entirely sensory. You squeezed it, stretched it, folded it, poked it. The fun came from interacting with the texture itself. Decades later, social media helped fuel a massive slime resurgence. Videos featuring glossy slimes, fluffy slimes, crunchy slimes, and countless other variations attracted millions of viewers. People discovered that watching and listening to slime could be oddly satisfying. For some, it became a hobby. For others, a business. One reason slime remains popular is the sheer variety available. Basic slime is only the beginning. Fluffy slime incorporates air and foam-like ingredients to create a lighter texture. Clear slime has a glass-like appearance that many people find visually appealing. Crunchy slime contains beads, foam balls, or other small objects that produce crackling sounds when squeezed. Butter slime spreads smoothly and feels almost like soft clay. Cloud slime is designed to create soft, drizzling effects when stretched. Each variation changes the sensory experience while still maintaining the core qualities that make slime recognizable. It's a surprisingly creative medium for experimentation. So we return to the original question. What exactly is slime? The simplest answer is that slime exists somewhere between a solid and a liquid. It belongs to a group of materials known as soft matter, substances that don't fit neatly into traditional categories. Slime can stretch, flow, deform, and recover shape depending on how it's handled. That's why it feels so unusual. It's not breaking the laws of physics. It's simply operating in a gray area that challenges our everyday expectations about how materials should behave. In many ways, slime serves as a reminder that nature is often more complicated than the categories we create. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.